Hi friends, in this video we are going to see the exploratory data analysis in data science and also the corresponding demo to work with exploratory data analysis in Python. So what is meant by exploratory data analysis? It is generally named as EDA, which is nothing but a data representation technique to understand the various aspects, insights about the data. In order to do the EDA, there are three steps. First, we need to understand the data. Next, the data need to be cleaned up. And finally, you need to analyze the relationship between the variables and to derive some insights from it. So in understanding the data, we need to understand what are the different types of variables available in our data set. So how many variables are numerical variables and how many variables are categorical variable. And followed by, you need to know how many number of rows available, columns available, then some basic statistical descriptions. All those will come under understanding of data. And next we are moving to cleaning of data. So while you clean the data, before the data need to be given to any machine learning algorithm, the data need to be clean. Maybe the data may have some outliers or some redundant data, and it may have some missing data, some irregularity patterns available, or some of the columns may not be necessary to further analysis. So they all need to be filtered out. And the last step is analyzing the data. So you need to find the relationship between the variables. So which variable is dependent variable, which variable is an independent variable, how one variable correlated with the another variable, the dependencies, so that you can able to derive some useful insights from that data. So these are the basic idea about the exploratory data analysis. So now we will see a demo in Python how you can do the exploratory data analysis for a given data set. So here I have a data set which contain the information about the car, the price of the car, age of the car, fuel type, HP, automatic, gear and the doors, name of the car, the price of the car, the modified price and the maintenance price of the car. And totally I have 25 rows. And here you see here this and the price, age, HP, automatic, then doors, new price, maintenance price, all will having a numerical data, and this fuel type and name is the categorical data. And again I have some of the data are duplicated. So here you see here the last two rows are duplicated rows. And now when I maintain this thing, I don't want to have this automatic because almost every value is 0. Only one car having a value is 1. So this column is not needed for me for further analysis. And some of the cells I'm having an empty value. See here in the maintenance and here in doors I have some missing values. So I need to understand the data. How many rows are there? How many columns are there? How many numerical data are there, how many categorical data are there. Then I need to identify to clean the data. So for that I need to find out which column is irrelevant and which are the empty cells, which are the duplicated values. So all those I have to analyze, and finally I need to find the relationship between the variables. So this is my data set. So I am going to work with Jupyter today. So this is my Jupyter notebook. To start with the demo, first I need to import the pandas library. Import pandas as PD. And by using the pandas library only, I can able to read the CSV file, and the data need to be handled as a data frame. Data frame is equal to pd dot read underscore CSV. I have to give my file name data underscore eda dot CSV. After reading, I need to display. So print df dot toString. So first I will run it, import the library. Next I run the file. Yes, so I got my 25 rows, whatever I have seen in my CSV file. And you have something here, 2 index values available. So you need to give a column, along with that index underscore column is equal to 0. So when I do that, I have only one index column. and there may be some time in your Excel file you may not have this index file. Okay, so I will delete this column and explain you. So I will save it. Yes, so this time I am putting the index column to be kept, but I don't have my index column in my CSV file. So now what will happen if you run the code? Your first column will be taken as an index column. Okay, but it's not correct. So that time you need to remove this index column. Okay, so please remember, you check your data first whether your CSV file having an index column separately. If it is separately available, you put here index underscore column equal to 0 to keep that column. And if I am not having that column in my CSV file, so here I am not having that column, so that time the first column will be taken as an index column. So you don't want to make it as a index column, so that time you don't put a separate index column equal to 0, so automatically your index column gets created. So this thing you keep it in your mind. And as you know, in the EDA the first step is understand your data. So I have displayed all the data. So now I want to understand the data, means I need to know how many rows, how many columns, all those things. So I can go with df.head. Then I can get only the first 5 rows. Then tail means last 5 rows. And then I can use with describe. And that will help me to give the statistical description. And then I can go with info, so that will give how many columns are integer type, how many columns are float type, then string type, all those informations will be there. So like that you can understand your data, and along with that I can give another function called as df.shape. So it will tell me there are 25 rows and 9 columns. Since you know here 1, 2, 3, 4, 5, 6, 7, 8, 9 columns you are having. So you have got the basic idea, that is understanding about your data. Next step is you need to clean the data. So cleaning can be identifying the outlier, redundant data, missing data, irregularities, unnecessary data. So in my data I don't need this automatic column. So that also I need to directly reflect in my data frame after removing. So in order to drop that column, you know the function df.drop. Which column I don't need? The column is the automatic. So if I simply put this, okay, so I need to tell again axis equal to 1 because it is a column. So this axis represents column wise the automatic column I need to remove from my data frame. It will not be removed in the CSV file, it will be removed only in the data frame. And also if I run this, it is temporarily only removed, but still I am having my df still having that automatic column. Okay, so if I do down, I print it, still my df column having an automatic. So what you need to do it, you know how to do it. So you need to add a property called as in place is equal to true. When I add in place is equal to true, in my data frame itself the changes get permanently reflected. So now I run it. Yes, so from the data frame itself the column get removed. So to analyze it, you need to put df dot shape function, so that will help you to check with. Since this automatic column is already removed, that's why you are getting this error. So I just execute only this shape. Yes, so automatic column is already removed, so I am getting only 8 columns now. Now I need to remove the duplicate rows and analyze. Since I know from my data the last 2 rows are duplicated. So in order to remove the duplicates, you have a function called as df.drop underscore duplicates. And you have a duplicate in 2 rows. Okay, so if I have option first, then if I have more than one duplicate, the first one will be kept, the remaining will be deleted. Okay, and there are various ways. Sometimes I have petrol itself, I have a duplicate, and I want to remove all the duplicates under the petrol. So that time what happened, I have 3 categories. Petrol is one category, diesel is one category, CNG is one category. So after I filter out, I will get only 3 rows. That also I will show to you. So when I use with duplicates, I am going to keep the subset as fuel type. Okay, so out of the fuel type, it will sort it, and how many duplicates are available in the fuel type, it will take care. And from that, it needs to keep only the first duplicate. So now what will happen, you just print df and see here. So out of the 25 rows, only the first duplicate value only kept. Okay, so it may reduce your data more. So if I keep last, means the last duplicated row only kept it. So now I don't want this. So I want to remove the entire thing which is duplicated. So that row only I need to remove it. So I need to again keep it df dot drop duplicates keep equal to first. So this time what happened, it will check every row, and in every column whichever rows get duplicated. So all values get duplicated. So if you see here, the entire row get duplicated as a separate row. So that row alone, in that it will keep the first one and it will remove the remaining duplicated values. And again I need to put in place is equal to true. Then only the changes get reflected in the same frame. So I am going to put df dot shape. Here you need to give shape, because shape is not a function, it is a property. So we are getting 24 rows. Since you know that the last row get deleted, so we have only 24 rows and 8 columns. And now I want to rename some of the columns. So I am changing the name of the column price to selling price. So how to rename? Know that a function called as df dot rename. So what I need to rename? I need to rename the column, and the column price I need to rename to selling price, selling underscore price. And this also I need to be reflected in the same data frame. So please remember, keep it as in place equal to true. Then you need to print the first 5 rows and check it. You need to put df dot head. So now the price is now changed to selling price. And next you need to drop the missing value and observe. Since you here, you know that there is a missing value in that particular cell. And here in the row number, this thing also, I have one empty value. So these two cells, wherever I have a empty cells, that rows I need to drop it. And I need to observe. So in order to drop, again I have a function called as df dot drop null. Drop the null values wherever the cell is empty, so that row get deleted. So in the row wise I need to drop it, and that also I need to make it as in place is equal to true. And after that I need to check what is the shape of my data frame. So 2 rows I have null values. So from the 24 rows, now I have only 22 rows after dropping the cells with empty rows. And the next thing, I need to analyze the data. In order to analyze the data, we need to calculate some statistical inferences. Okay, so you need to do some statistical inferences. Basically, we have two things. One is a central tendency and another one is the variability measure. Under the central tendency, we have something called as mean, median and mode. And in the variability measure, you need to check the variability of the data. Central tendency means central information about your data. You have a range of data. From that, you have to know the centrality about your data. So you have a central tendency. Variability means how your data has a variance. So you have an option called as range, and then you need to calculate the variance and you need to calculate the standard deviation. So first I am going to calculate the central tendency about the age column, because age only have a variation from minimum range of the age of the car to the maximum age of the car. So how it is variance and how many ages repeated, what is the mean, median. So all those things I need to calculate it. So I am going to print the mean value for the age column. So I need to take the age, then I need to calculate the mean. So like that I need to repeat for median, df age dot median, and then I need to calculate print mode and df of age dot mode. So why we are calculating these things? Since you know, for filtering the data, we have removed the unnecessary column, we removed the null values. There may be some outliers in your data. So the outliers can be easily identified by the mean, variance and the standard deviation. So that only we are going to analyze using these mean, median and then variance and the standard deviation. So now we need to calculate the variability measure. So first I need to calculate the range. In order to calculate the range, I need to find out what is the minimum value, what is the maximum value. So I need to calculate the minimum is equal to, in the age column, what is the minimum value. Then I need to get the maximum value. So in the age column, what is the maximum value. And then you need to print it. You can print M and N, so that you need to know what is the minimum value and what is the maximum value available in the age column. From that you need to calculate the range of the age. So in order to calculate the range, I need to put range, that is maximum minus minimum range. And then I need to calculate the standard deviation and variance. First I need to calculate the variance, df of age dot variance, and then standard deviation, the formula is df of age dot standard deviation. Okay, so when I run it, yes, I will get the range, variance and standard deviation. So now my data not having any outliers, because all my data range of the ages within the range of minimum of 22, maximum of 32. And there is another measure based on your range and based on your quantile. Okay, so since you know in the describe function we have seen 25% quantile and these 50% quantile and the 75% quantile. So this IQR will help you to use these quantile information and to calculate the IQR. This IQR is mainly used to identify your outliers. Using this IQR, you can identify the outlier and you can remove it. Same thing, we have something called as Z score. This Z score also a statistical information related to your data. By using the Z score also, you can identify the outliers and remove your outliers. So now I am going to calculate the IQR. The formula for IQR is 75% quantile minus 25% quantile. So first I need to find out what is the 25% quantile and the 75% quantile. So Q1 is equal to, I need to calculate for the 25% quantile. I am going to give 25. Then I need to calculate the quantile for the 75%. That is age dot quantile 75%, because the formula for IQR is Q3 minus Q1. So now I need to print the IQR value, that is a difference between Q3 minus Q1. So I got the quantile value. Later we will add some outliers, and then we will analyze how the outliers affect in the mean, variance, standard deviation, IQR and the Z-score. That's why we are calculating without outliers how these values are available, and after adding outliers how these values get reflected. Okay. And now I am going to calculate the Z-score. Z-score is a statistical measure, so generally it will be calculated as Z is equal to the X value minus mean divided by standard deviation. Okay, so this is the formula for the Z-score. For every value, the total mean will be subtracted from the individual value divided by the total standard deviation of the entire data set. That is the way the Z-score will be calculated. So in order to calculate the Z-score, I need to import the library called as stats library. So first I need to import it. Import SciPy. SciPy is a scientific library. In that I have a stats. So I need to add the stats library. And using the stats library, you need to calculate the Z-score. So Z-score is equal to stats dot Z-score df of, for which column, that is the A column. Then I need to print the Z-score. Z-score. So I run it. Yes, I am getting a Z-score for every value. Okay, so I have totally 20. How many rows I am having? Totally I am having 22 rows. For each age value in the 22 rows, the corresponding Z-score value will be there. Okay, so now I am not having any outliers, so all my Z-score is having a value less than 3. If my value of the Z-score is going above 3, then that may be an outlier. Since I can see here I am not having any values with the Z-score is greater than 3. So now I need to find out a heat map. This heat map only give you the relation between the variables, how one variable is related with the another variable. This is again called as a correlation map. Okay, so in order to do this correlation or heat map, we need to include a library called as C-bond library. So C-bond as SNS. Using that library, I am going to plot the heat map. So SNS, first I need to find out the correlation. So C is equal to df dot correlation. So how one variable is correlated with the another variable, I need to find out, and after that I need to draw the heat map. So heat map of C comma X tick labels is equal to C dot columns, Y tick labels is equal to C dot columns, and not is equal to true. Okay, so now I will run it. Yes, so this is my heat map. So all these values represents positive correlation and negative correlation. So since door it having a common value, so it's not included here. And you see here, when you consider with your selling price to selling price, always the correlation is 1. And but if you go with the selling price increases, the new price also increases. So that is a positive correlation. So then the age of the car increases, your selling price decreases. So it is a negative correlation. Okay. And the age of the car increases, the maintenance cost also increases. So it is a positive correlation. When the age of the car increases, the selling price decreases. So it is a negative correlation. So we have represent the positive correlation and the negative correlation. How one variable is related to the another variable. How you can identify also the dependencies between these variables using this correlation map. So by using the heat map, you can able to identify which variable is positively correlated to another variable and which variable is negatively correlated with another variable. Okay, so since I take age and selling price, I know that when the age of the car increases, the selling price of the car decreases. The age of the car increases, the maintenance cost also increases. So it's a positive correlation and it's a negative correlation. So from this analysis, you can able to identify the relationship between or the correlation between the variables. Suppose I need to do a correlation only with age, maintenance and the selling price. So what I have to do is, I need to take only that column separately from my DF. I need to take age column and I need to take selling price, and then I need to consider maintenance. So for them alone, I need to calculate the correlation. So I need to pass that correlation alone. Yes. So from here you have a clear idea. So the age increases, the maintenance cost increases. The age of the car increases, the selling price of the car decreases. So this is a positive correlation and this is a negative correlation. And now I am going to add two data frames along with my previous data. So since I know previously I have how many datas? Totally so far I have 22 rows. So now I am going to add extra 2 rows with my data set which have some outliers. You see here the age value I have added with 90 and another age value I am making as empty. So these two things I am going to create as a new data frame and add in my previous data frame. So the first data frame I am going to keep the value, these values. So I have already kept it here. So I just put it here. Okay. So since I know I am having a selling price column, yes, then the next column is age. So I am keeping as empty. Okay. Automatically it will take a null value. Then fuel type, HP, door, name, new price, maintenance, everything I am going to have it. And for the second row also I am going to keep the value df2 is equal to the second row also I am going to keep. So here age value I didn't put in the first row. So automatically it will take that as a null value. Okay. So how I can add these two new rows inside my previous data frame? So I need to use with df dot append df1, this new row to be added at the end of my previous data frame. So I need to give ignore index is equal to true, and also this reflection should be happen in the original data frame. So the result should be stored in my original data frame. So same thing I need to repeat for the second data, that is my df2. After that I just try to print it df dot tail. So the last 5 rows I need to display. Yes, so here you see here the 2 rows whatever I have added newly, it's added. The first row I didn't give the age column, age value, so it becomes null. Okay, and you see the data now I have changed the range to 90. So I have added some outliers in my data. And now what I am going to do is I am going to add a new age value. So instead of 55 I am going to add a 85. Okay, so I am going to replace wherever null values are there, it should be replaced with the value 85. Since I know in my age column only one cell I have an empty, so that cell alone it will be replaced with 80. Fine. And now it should given us df dot replace. I need to specify to replace. What I need to replace? I need to replace all the null value with the value called as 85. And that also it need to be reflected in the same data frame. So in place is equal to true. So this NP represents the NumPy library. So I need to import NumPy as NP. So I need to print it df dot take. Yes, see here now 85 is added previously. So now I have added some outliers. As I already told you, the mean, variance, standard deviation, IQR and the Z-score. These are all mainly used to identify the outliers in your code. Okay. So now I'm going to check. First I'm going to use my box plot and I'm going to check whether there is some outliers available. So box plot is a graphical representation where you can identify the outliers. So I need to use the box plot that is available in the Seaborn library. That is categorical plot. I need to put for the age column and I'm going to specify the type of the plot is box plot and I need to apply for the data df. So yes, you can see here now I have two outliers with a range of 85 and 90. So I know that now my data having some outliers. So that I am going to verify with my mean, variance and standard deviation. So since I have calculated already the mean is 27, the variance is 9, the standard deviation is 3. Okay, so now how it is going to change after your outlier 27, 9, 3. So now we will see here. So mean, then I need to put variance and then I need to put standard deviation. You know that 27, 9, 3. Now you see how the values are changed. 27 is now changed to 32. 9 variance is changed to 298. Standard deviation, previously it is only 3, now it is 17. So by adding the two outliers, your entire data's information got confused. Okay. And now using a concept of your IQR and the Z-score, we are going to identify which two rows having the outliers and that get removed. Okay. So the first step is again I am going to calculate my IQR. Since I know that, I just copy and paste the code for the IQR. Previously it is 5. So now I will place it. So now also it is 5 only, but by using this I can able to analyze. Okay, I am going to remove that. How I am going to remove it? So first I need to find out the lower limit for removing. That is, the lower limit will be Q1 1.5. So I need to identify which is the lower limit of my data set, what is the upper limit of the data set, and whichever coming out of that, everything should get removed. So that I am going to decide with the IQR. So I am going to calculate the lower limit and then I am going to calculate the upper limit. So after that, using for the column age, I am going to apply this. I am going to filter out whichever data is greater than the lower limit and whichever data is greater than the lower limit and whichever the age value is less than the upper limit, all those only I need to keep it. Okay, all those only I need to keep it from my data frame. That I am going to store it in a separate output. So this output frame will not have any outliers. Okay, I am going to filter out whichever age is greater than lower limit, and whichever age is less than upper limit, that data is only I am going to keep it, because that is not having any outliers. So that I need to again in the shape df.out.shape. So I will run and check IQR. So I didn't store it, so I need to store it. IQR is equal to Q3 minus Q1. Yes, so now you see here, after adding I have 24 rows, but now after removing the outlier I am having only 22 rows. So I can see with my df.out.tail. See, the last two rows get removed, which is having outliers. So same thing I am going to check with the box plot, which is not for the original data frame. I am going to check for my outlier removed data frame. Yes, so now my outlier get removed, okay, by using the IQR technique. Same thing I am going to apply for the Z score. By calculating the Z score, I am going to identify the outliers and then I am going to remove it. So this is the way how you calculate your Z score. Go and keep it. Your Z score here. Yes, Z score is ready. So you want to run it. Now you see, I told the outliers having the Z score is greater than 3. So you can easily identify which are the rows having the Z score is greater than 3. That rows are outliers, so it should get removed. So after calculating the Z score, I need to filter out. So for filtering, I am applying which are all the rows having Z score is greater than 3. So it will return if a particular row is having Z score greater than 3, it will return true, otherwise it will return false. So based on that, I will identify that rows I need to filter it out. So my new data frame contain only the filtered data. So same thing again I use with new underscore df, apply the tail. So it is greater than 3 means that last two rows I am having the outliers. That two rows I have extracted. So now I need to remove the outliers. So I put less than 3. Less than 3 means the rows which are not having outliers. Yes, so the last two rows get removed. That last two rows only I have outlier. If I put the box plot for this, I put a box plot, new underscore df. Yes, again my box plot is confirming me using the Z score. I have identified the outliers and I have removed it or filtered out that outliers from my data. So my data get cleaned now. So by using the exploratory data analysis, you have understand about the data, you have made cleaning of your data by removing the null values, unwanted columns, dropping, then identifying the outliers, removing the outliers, and finally you have analyzed the data by using the heat map, how it is correlated, and by using the central tendency, variability measures, IQR, Z score, that all helped you how your data's behavior is, so that you can analyze or you can find out some insight about your data. So that is the overall thing about your exploratory data analysis in the data science. And now whatever the two rows I have added in my data frame that I want to drop, only the last two rows, that is the outliers, whatever I dropped, I want to remove it from my original data frame. So in order to drop, now I am going to drop the rows. So when I drop the rows, I need to give the index number of the rows. Okay, so since I know so far I have the rows 22 and 23 is my outlier rows that I want to remove it from my original data frame. So I am giving that index number here, and after removing it should be reflected in my original frame, and I need to give shape and I need to give df dot to string. So my entire data get printed to me. Okay. So I have removed all my outliers, whatever I have it in my original data. So I have kept it as my data frame. So because when you want to do with your machine learning algorithm, your data need to be first analyzed. Okay, because the errors in your data may affect your machine learning algorithm accuracy. So you need to do the exploratory data analysis before you go up with any machine learning algorithm. That's why we have studied these steps for your exploratory data analysis. So you follow these exploratory data analysis process to understand or to identify some insights about the data available in your data set. Thank you.